Title of first section of notes is Evaluate. For a variable. Directions for this one are solve when w equals 6, x equals 0.4, y equals 1/2, and z equals -3. First question, w plus 12 divided by z. Given the previous four values, we can plug in for the variables and then solve. For example, w equals 6, so we'll put a 6 in place of w. Plus 12 stays the same, and divided by z, z is -3, which I'll put in parentheses. This problem we have addition and division. If you remember PEMDAS, the order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. We'll do division before we do addition. So 6 plus 12 divided by -3 would be -4, and 6 plus -4 equals 2. Second question and last question for the section. W minus 3x plus y, and we'll solve this using the previous values given. W again is equal to 6, 3, and instead of x we'll put the decimal value 0.4, and plus y, y is 1/2. Solving this, we have subtraction, multiplication, and addition. And again, we want to follow PEMDAS. PEMDAS, we're going to do multiplication first, and then we have addition and subtraction. -3 times 0.4. If you multiply that out, that'll be minus 1.2. And plus, instead of 1/2, since we already have a decimal, I'll change 1/2 into a decimal, which would be 0.5. Solving from here, keep in mind we're following PEMDAS. One step on PEMDAS that's most commonly forgot is multiplication, division, and addition, subtraction. You do each of these operations at the same time in order from left to right. So even though addition looks like it comes before subtraction, these are paired, and you do both operations in order from left to right. So we'll subtract first and then add. 6 minus 1.2 would be 4.8, and plus 0.5. Adding those together will give you the answer of 5.3. Title of the next section notes is More Evaluation. Directions are solve when A is equal to 2/5, B is equal to -3, C is equal to 0.5, and D is equal to 6. First question, b to the fourth power minus d. Again, taking the four values given, we can plug in and solve. B is equal to negative 3, which again I'll put in parentheses, minus d, d is equal to 6. We'll do exponents before subtracting. Negative 3 to the fourth power would be negative 3 times itself 4 times. Negative 3 times negative 3 would be positive 9. 9 times negative 3 would be negative 27. And negative 27 times negative 3 would be positive 81 minus 6. Subtracting, and the answer would be 75. Second question and last question for the section. In parentheses, a minus c squared minus 2bd. Again, plugging the values in. A is equal to 2/5. C is equal to 0.5 squared minus 2. B is equal to negative 3. And D is equal to 6. Solving from here, we'll do parentheses first. 2/5 minus 0.5. 2/5 you can change to a decimal by using a calculator or long division. That is equal to 0.4 minus 0.5 squared. Subtracting these decimals would be negative 0.1 squared. Rewriting the rest of the question, we have minus 2, negative 3, and positive 6. Exponents we'll do next. 0.1 squared. If you multiply that out, that would be 0.01. And multiplying the rest of the numbers, negative 2 times negative 3 would be positive 6. Positive 6 times 6 would be 36. So we have 0.01 plus 36. So our final answer would be 36 and 1/100th. Solving this problem, we'll take the formula of the volume. Volume is equal to 1/3 pi r squared times the height. Given the information, r is equal to 3x and h is equal to 2x, we can substitute those in for the variable. So the volume would be 1/3 pi. Instead of r, we'll put 3x. I put it in parentheses since the quantity will be squared, and h would be 2x. Simplifying from here, following PEMDAS, we'll do exponents first. So volume equals 1/3 pi. Squaring the parentheses, we'll square the number as well as the variable. So 3 squared would be 9, and x squared would be x squared. And next step, we can multiply. 9 times 2 would be 18. 1/3 is like dividing by 3, so we'll have 18 divided by 3, which would be 6. Pi would stay the same. And x squared times x would be x cubed, or x to the third. So our final answer would be 6 pi x cubed. For sets of numbers, we have 6 different sets. The first one, R, which stands for real. All real numbers. Every number you've seen in every math class up until now is a real number. The only exception later on this year will cover imaginary numbers. Q stands for rational. Rational is basically any fraction, any number you can write as a fraction as long as the denominator and numerator are integers, and those would be positive or negative whole numbers. Integers, we'll use the letter Z. Integers, again, are positive or negative whole numbers. Anything that's on the number line except for decimals and fractions. Whole numbers, we'll start at 0 and count up. So 0, 1, 2, 3, 4, 5, and 6, and so on. Natural is almost the same thing, but it starts as 1 and counts up. 1, 2, 3, 4, 5, 6, and so on. And last one, I, for irrational. Irrational is a number, is a decimal that does not repeat or terminate. If it repeats or terminates, it's rational. You can write it as a fraction, but if it does not repeat or does not terminate or end, it is irrational. And it's also a square root that cannot be simplified. Title for the first section of the problem is name the sets of numbers to which each belong. First number we'll look at is the fraction 12 over 2. And we'll take this number and go through these 6 sets of numbers and see if it belongs to that set. Every number could belong to at least one set, and most belong to more than one set. 12 over 2, it is a real number. Again, every number is a real number until we get to imaginary numbers later on this year. Rational number is anything that can be written as a fraction. It is a fraction, so it is rational. It is also an integer. Doesn't look like an integer right now, but if you simplify it out, 12 over 2 is equal to 6, and 6 is an integer. It's also a whole number. 6 would be part of the whole numbers, and also part of the natural numbers. It is not irrational. It does not have a decimal that does not repeat or terminate, and it's not a square root. So the 5 sets of numbers: real, rational, integer, whole, and natural. Second number we'll look at is the fraction -2 over 9. Again, we'll take this number, go through all 6 sets of numbers, and see which it belongs. It is a real number. -2 over 9 is also rational because it is a fraction, could be positive or negative. It is not an integer though. 2 does not divide evenly into 9, and therefore it's also not a whole number or natural number, and it is not irrational. 2 divided by 9, if you wrote it out in decimal form, the decimal would repeat or terminate. So this one is only real and rational. And last number for the section, the square root of 19. Again, square root of 19 is real. Every number is real until we get to imaginary numbers. Rational means you can write it as a fraction. You could change this into a fraction by putting it over 1, but the fraction has to have whole numbers or integers, cannot have square roots in the fraction. So it's not rational, therefore it's also not an integer, whole number, or natural. Square root of 19 cannot be simplified, which means it's an irrational number, a square root that cannot be simplified. There's also 4 properties in mathematics we can use with numbers. The commutative property, a plus b equals b plus a, means it doesn't matter which order you add the numbers, it'd be the same total. Associative, if you have 3 numbers, it doesn't matter which 3 numbers you add or how you add them together, it always adds to the same. Identity, if you add 0 to any number, it stays the same. Inverse, if you add the opposite of a number, it always adds to 0. For multiplication, the same 4 properties. Commutative, it doesn't matter which way you multiply 2 numbers. Associative, if you have 3 numbers, it doesn't matter how you multiply 3 numbers, it's always the same total. Identity, if you multiply by 1, it stays the same. And inverse, if you multiply by the reciprocal, it's always equal to 1. One extra property is distributive, where you can distribute a times b and a times c. Next section of notes is titled Name the Property. First question is 5a plus, in parentheses, negative 5a equals 0. Looking at the list of properties where you add the opposite and it's equal to 0, that is the inverse property. And also we're adding to make 0, so that would be inverse addition. Second question and last question for the section. In parentheses, 2 plus 14 plus 3 equals 3 plus, in parentheses, 2 plus 14. In this case, it looks like associative, but if you look closer at the problem, 2 plus 14 stays the same in each of the parentheses. It just changes from the first term to the second term. So this is actually commutative. And again, since we are adding, this is commutative addition. Title of the last section of notes is Simplify. Expressions. First problem, 7a plus 3b minus 4a minus 5b. Simplifying this expression, we can combine like terms. Like terms would be the same variables, so the a's we can put together, and also the b's we can put together. 7a minus 4a would be 3a, and 3b minus 5b would be negative 2b. So our final answer would be 3a minus 2b. Second question and last question for the section. 3, inside parentheses, 15x minus 9y plus 5, in parentheses, 4y minus x. Solving, we can use distributive property on the first parentheses, multiplying 3 by each of the inside terms. 3 times 15 would be 45x, and 3 times the negative 9y would be minus 27y. We can also use distributive property on the second set of parentheses. 5 times 4y would be 20y, and 5 times a minus x would be minus 5x. And again, we can simplify by combining like terms. The x's we can put together and the y's we can put together. 45x minus 5x would be 40x, and negative 27y plus 20y would be negative 7y. Title of the first section today is Solving Equations. First problem, negative 14 plus n equals negative 6. Solving for n, we can get rid of the negative 14 by adding 14 to both sides. Negative 14, positive 14 would cancel, and negative 6 plus 14 would be 8. So the answer n equals 8. Second question and last question for this section. 4 in parentheses x minus 1 minus 3 in parentheses x plus 2 equals 25. First step on this one is distributive property. Distributing the 4 to the parentheses, we'll have 4x minus 4. And distribute the second parentheses, we'll have negative 3x. And the second number is negative 3 times 2, which would be a negative 6. Equals 25. Combining like terms, 4x minus 3x will just be x, and negative 4 minus 6 would be negative 10, equals 25. Add 10 to both sides, and x equals 35. Next section of notes is titled Solving for a specified variable. First question, v equals 1/3 pi r squared h, and we want to solve for h. What this means is this equation, we want to get h by itself, so our answer would be h equals all the other variables on one side. To isolate h, we can cancel out the 1/3, the pi, and the r squared by dividing by each one of those. Dividing by 1/3, dividing by pi, and dividing by r squared. And we'll do that to both sides. Bringing down the question, we'll have v. When we divide by a fraction, dividing by 1/3, we can flip it upside down and multiply by the reciprocal. So instead of dividing by 3/1, we can have, instead of dividing by 1/3, we can multiply by 3/1. the pi would stay in the denominator, and the r squared would stay in the denominator. The 1/3 pi and r squareds cancel, and we're left with just h, which would be our final answer. 3v divided by pi r squared. Second question, and last question for the section. 4y minus 2n equals 9. And we're solving for y. Again, if we're solving for y, that means we want to isolate y and get y by itself. So our final answer would be y equals. First step in this one is to add 2n to both sides. 4y would come down, minus 2n and plus 2n would cancel. Normally in math, we'll put the variable first before the number. So I'll write this as 2n plus 9. And last step, we'll divide by 4. So our final answer would be y equals. Always check to see if you can reduce fractions. The 2 and the 4 can be reduced, but the 9 can't be reduced with it. So it would just stay the same as 2n plus 9 divided by 4. Perimeter of a regular octagon is 124 inches. Find the length of each side. From geometry, a octagon has 8 sides. A regular octagon means every side is the same length. So the perimeter for a regular octagon, would be 8 times s. 8 times each of each side, because each side is the same distance. Equals, from the problem, 124 inches. Solving from here, we can divide both sides by 8, and s equals. 8 doesn't go in evenly to 124, but we can reduce fractions. In this case, you can divide the numerator and denominator by 4. So our final answer would be 31 over 2. Each side would be 15.5 inches, or 31 over 2. Title of the first section is Evaluating. Absolute values.